Welcome to Physics Clinic at the RedRose Academy. Let's be honest, every time you see a pedigree chart in a NEET mock test or any school test, your brain does a little time dance. You start tracing generations, writing down capital A's and small a's, wasting 3 whole minutes only to end up guessing option B. So stop doing that. In this video, I'm going to give you a three-step process, three-step analysis from the Physics Clinic at the RedRose Academy that will let you crack any pedigree chart in exactly 10 seconds. No heavy genetics theory, just pure unfiltered logic. So drop a like, grab your notebook, and let's score these 4 marks. Okay. So now, before I give you the cheat code, let's quickly establish the language of pedigrees. You already know this, but let's lock it in. Okay. Squares are males. Okay. Circles are female. Okay. And then if they are shaded, they have the disease or trait. If they are connected by a horizontal line, they are married. Okay. So if it is diamond, it is unknown. Okay. Used when the gender of the individual is not specified or recorded in the historical family record. So that is what it says. Okay. And there are 4 types of disorders also. I'll teach you that. See this connecting line. See mating line, that is in a match. So single horizontal line connect a male and a female. Okay. So consanguineous. So consanguineous means a double horizontal line indicates marriage between close relatives. That is a red flag for recessive traits. Okay. So consanguineous means this Guinness will give a double horizontal line. That definitely indicates recessive traits. And vertical lines, if you're taking, okay, extend from mating lines to the offspring generation. So the marriage between the male and the female to the offspring generation. And then sibling line means horizontal lines above siblings. Okay, ordered from left to right, like that, eldest to the youngest. So these are all the line of descent I can able to say. Okay, so I told you the 3 steps. Okay, so first you must know the recessive cheat code. Okay, so what is the recessive cheat code? You must know. There are so many things you have to understand and everything. So the hidden carrier rule. So what is the skip generation gap? So why I quoted this name? If you see 2 unaffected parents, normal parents, having an affected child, it is strictly recessive. Okay. So parental genotype, both must be heterozygous. So they are the carriers like capital A and small a. This is recessive only. Okay. So it's a hidden carrier rule. And then you must know the gender bias. Okay. So what is meant by the autosomal traits? So affected individuals are roughly equal between males and females. Okay. So no specific sex preference in transformation. This transmission, you didn't prefer any sex. Okay. That means sex linked traits, we can say. This is autosomal means irrespective of the sex preference, affected individuals are roughly equal between male and female, like that. So this is sex linked traits, significant bias. What is this? What is the significant bias in X linked recessive? Many more males are affected. Okay, in X-linked dominant, affected fathers pass to all daughters. So this is what happening in the sex-linked traits. This is very important topic. You can make a note of all these things. Okay, and okay, I'll come to this. So there are 4 types of disorders you must know. One is autosomal dominant, autosomal recessive, X-linked dominant, and X-linked recessive. Okay. See, we saw what is autosomal. Autosomal is irrespective of sex transformation. Sex transmission, sex preference is not there. Okay, 50% equal between. affected individuals are roughly equal between male and female. But sex-linked traits means X-linked recessive means many more males are affected. X-linked dominant means affected father passed to all daughters. Okay. Now I'll teach you this 4 types of disorders. Okay. If you try to test all 4 possibilities on a chart during the exam, you run out of time. Okay. So here is the secret workflow. Okay. So I'll teach you all these things. Okay. And then you must understand what is the autosomal dominant. So this is no skipping. Okay. Autosomal recessive is skips generation. Okay. So in autosomal dominant, affected parent. Okay. So this is affected parent. That is right arrow, affected child. Okay. Like that. Then autosomal recessive is normal parent. Right arrow, it indicates affected child, like that. Skips generation. Okay. So X-linked dominant means no skipping. Dominant or all or no skipping. Okay. So father passes to all daughters. X-linked recessive means mostly males. So mother passes to all sons, like that. Okay. So, for example, okay, look at the chart. So look at the chart globally, I can say. Don't look at individuals. Just ask yourself one question. Just what is that question? Does this disease skip generations? If it does not skip generations, meaning every single affected child has at least one affected parent, it is dominant. It's an aggressive trait. Okay. It shows up everywhere. If it skips generations, meaning 2 completely normal looking parents suddenly give birth to an affected child. So it is recessive. Can you able to understand? If it does not skip generation means every single affected child has at least one affected parent. It is dominant. It's an aggressive trait. Okay. If it skips generation means 2 completely normal looking parents suddenly give birth to an affected child. So it is recessive. The parents were the secret carriers. Okay. So it is the, I can say the golden rule for recessive. So it is the recessive is unaffected parents leads to affected child. That is recessive. Okay. So unaffected parents. So make a note of all these main points leads to affected child. So that is recessive. Okay. Okay. Then I can say, suppose once you know if it is dominant or recessive, how do you know if it's on the X chromosome or an autosome? So look at the gender bias. If the disease is attacking males and females equally, it is autosomal. Okay. If there is a massive bias, like mostly males are suffering, it is likely X-linked recessive. Okay. So, okay. So, but don't guess. Use my foolproof cross checks. So this is crisscross pattern. Listen. This one. Unaffected parent. Okay. Affected parent. This shows unaffected parent. This is affected parent. Okay. So this one is muted gene and normal gene, like that it represented. So it directly goes to affected children. This is unaffected children it produces. So autosomal dominant inheritance means it might be unaffected parent also or affected parent also, that leads directly to the affected children and unaffected children. So this is actually dominant. It is aggressive trait. Okay, it is dominant, autosomal dominant. Autosomal recessive is the parents are the secret carrier. These parent, this parent is the, they are the secret carrier. Okay, so this carrier parent, what they did, they produce carrier children. There also you might have seen the unaffected parent which is producing unaffected children. So this what it has happened. The parents are looking very normal, but they are carrying the secret. Okay, they are carrying the recessive thing in a secret way. So this is X-linked recessive. Okay, so this is very important thing you must understand. If you think it's X-linked S-linked recessive, that is X-linked recessive. Okay. Look for the crisscross inheritance. This is the crisscross pattern. See, observe the crisscross inheritance. Like, see, understood? Like this, you have to learn. I'll explain you again. In this, you must observe this pattern. So this is the crisscross analysis. You must inheritance, I can say. Okay. An affected mother must pass it all her sons to all her sons. Why? Because a son gets his only X chromosome from his mom. That is the problem. If mom is affected, okay, the son is also getting the affected chromosome. Like, so this is defect, okay, defect chromosome X. This is mom. So from the mom, the son also getting the same X. So X defective, and the father might be, okay, unaffected. So it is guaranteed to be affected. The child or son has to be affected very, very, it's sure. Okay. If you see an affected mom with a normal son, boom, it cannot be X-linked recessive. Okay. See, for example, observe this pattern. So definitely affected son inherits X from mom. Okay. See, for example, here, this crisscross pattern. Okay. Unaffected parent and affected parent, they can produce unaffected children. And so unaffected parent can produce unaffected children as well as affected children also. It also possible. Okay. Like this. Clear? And affected parent can produce the affected children. Very rare, they may produce normal children also, unaffected children also. Okay. So this is what autosomal character. Okay. So what if you think it's X-linked dominant? This is X-linked dominant. This is X-linked, this is autosomal, and X-linked, I will explain you. This one, this is actually an autosomal. Autosomal means equal. Okay. So male and female, they suffer equally like that. So it is not dominant to son or not dominant to daughter. So it happens equally. It is not biased. Okay. But X-linked means it is biased. Okay. So look at the affected father, for example. An affected father passes his X chromosome to all his daughter. That is what happened. Okay. Then, so an affected father must have all affected daughters. This is very sure. If he has a normal daughter, it is not X-linked dominant. Okay. Make sure, make all the points clear. Okay. This is very, very important. Do take a notes. So it is very easy for you to understand. Okay. So we will see some topic based on this. So I'll share this question to you. Okay. This is one of the question my students asked doubt. So looking closely at the pedigree chart, I'll give you the explanation for all these things. Okay. What about the generation one? Both the parents are normal, right? So that means we can say unshaded square and circle. Unshaded means they are normal. Okay. And what about the second generation? You can see an affected son. Who is this affected son? Okay. Shaded square. Okay. Then what about the generation three? Two normal parents. in the second generation also give birth to an affected son. So this is all about this picture. So what is the first question? Identify whether the trait is dominant or recessive. You know, what is our, uh, my tip to you? So look for the generation skipping in both instances where the disease appears. Okay, it pops up out of nowhere from completely unaffected parents. So what is the rule I told you? Unaffected parents, they will give affected child. So what is that? The answer is recessive. Okay. So this is the first logic rule I will give you. Just make a note of this. Unaffected parents, keep this in your long-term memory. Okay. It will take, so you can use this generation skipping. Okay. So it will take at least, half a second, half a minute like that to solve all these questions. Okay. So unaffected parents, make a note of this. Unaffected parents, affected child. This is called recessive. It is equal to recessive. Okay. So what is the next question? Why do the parents in generation 1 not show the disease, yet their offsprings do? Now you can able to answer this question also after listening all the lesson I took before. Okay, because what is the answer? The parents are heterozygous carriers for the trait. How about the parents? Heterozygous. Okay, heterozygous carriers. So what does it mean? Since the trait is recessive, it requires 2 copies of the defective allele to actually manifest as a disease. Okay, so the parents each one carry normal allele, okay, dominant allele, which masks the disease, allowing them to appear completely healthy while silently passing the hidden defective allele down to their child. That's what happened in this. This is heterozygous carriers. Okay. Then what are the possible genotypes of the parents in generation 1? It is asked the next one. We know both parents must be heterozygous. That is A, small a, like this. So let capital A be the normal allele. This is normal allele. This one is normal allele. Okay. And small, so see, for example, small a, it represents recessive. Recessive, actually disease causing allele. For the affected son in generation 2, show the disease. His genotype must be homozygous recessive. So how about this particular affected son in the second generation? This here, his gene is homozygous recessive. Okay, AA, small AA. Then he inherits one A allele from his father and one A allele from his mother. That's what happened here. Got it. Since both the parents are phenotypically normal, they must also possess a dominant A allele. Therefore, the only possible genotype for both generation 1 parents is AA. Okay. Can you able to understand? This is what happened. Okay. So this is the answer for, these are all the answer for the questions. Let me give you a very quick recall of all these stuffs. So memory, you have to keep this in your memory. Okay. So you must remember all these sentences, what I taught you. Just go through the video again and again. Okay, very, very important. Okay. What have happened if healthy parents leads to affected child? Definitely autosomal recessive. Okay. So every generation affected means, what is the answer? It is dominant. Every generation. That means first generation also affected, second generation also affected means dominant. Make a note of this. This is very important. Let me give you a very good uh, conclusion for this. These points are very important for you. Okay. So every generation affected means dominant. Every generation affected means dominant. Okay. Only males affected means what is that? What is the answer? Only male affected. So this, what is that? Likely X-linked recessive. Okay, X-linked recessive. Okay, then what about father passes disease to son? That is autosomal, right? Father passes disease to son means that is recessive, right? Autosomal. Okay, then from this, you must know about all these things, okay? But pedigree analysis is not about memorizing. It's about thinking the Sherlock Holmes. Every pedigree tells a story. Every generation gives clues. Every symbol reveals evidence, okay? So the student who follows the clues wins the mark. Okay? Thank you. I'll catch you up in the next video. Bye-bye.